if you are trying to show that two functions are inverses, it says in the instructions how to do it. You have to just use composite, and this is both. So we are requiring you to do it both ways if that's in the instructions. So you have to plug G into F, and then simplify, and then also F into G, and then simplify. And you just have to show me that both ways is going to equal X. So just pick one way. So let's start with G of F of X. So we're going to take F and plug it into G. Take F, plug it into G, into the X there. So this becomes 2 times X plus 5 plus 1. And then we simplify. So 2 times X, 2 times 5 plus 1. The only thing we can simplify at this point is the plus 11. So since it did not simplify to X, then this is going to be a no. These are not inverse functions. Okay, we don't even have to try the other way, because if both ways don't work, then it's not going to work. So let's try this set of functions down here. So let's try G of F of N. So taking our F function, plugging it into G. So instead of 2n minus 2, it's going to be 2 times our whole f function minus 2. So let's try this out. So let's distribute. You have to show me every single step that you're going to do. So 2 times a half n just gives me n. 2 times 1 gives me 2 minus 2. And then this case, this is going to equal 0, so those will cancel out, and we just are left with n. And that's what we want to happen. But now remember, instructions, you have to show both ways. So let's plug G into F. So let's do F of G of N and see what we get there. So instead of 1/2 n plus 1, it's going to be 1/2 times the whole G function plus 1. So we distribute minus 1 plus 1. And then those will cancel. We're left with n. So both times, all of our operations canceled, and we're just left with the variable. So if that's the case, this is going to be a yes. These two are inverse functions since all of the operations canceled out with each other.